Okay, so today we're going to go over factoring. I know it can be scary sometimes. But before we start factoring, we want to make sure we have the right background information. So the first thing we need to know is a polynomial. A polynomial is a collection of terms with addition that have variables. In particular, today we're going to look at a trinomial, which is a polynomial that has three different terms. We also want to know what like terms are. So when the variables have the same power, it's going to be considered a like term, and we can combine those. And then our general form for a polynomial is ax squared plus bx plus c, where x is our variable, a, b, and c are constants. We also want to know what factoring is actually intending to do. So when we factor, what we're doing is we're trying to break something into smaller, less complicated pieces. So if we have a really, really big, crazy equation that doesn't really mean anything to us, but when we break it down, we can start to pull out important information. We also need to know what our greatest common factor is, and that's going to be the largest factor that the terms share in common. And then we also want to make sure we pull back onto that FOIL information that we've learned already. So today we're going to learn two different methods of factoring. We have the AC method and the guess and check. For the AC method and the guess and check, ultimately, the first thing we want to do is combine any like terms that we have and make sure it's in general form. So we can see in the first example we had 9x plus 5x, and we could change that to 14x. And here we had, in the second one, 2x squared minus 2x squared, which means that those are going to end up canceling out, and then our 9x and x added together to come to 10x. In the bottom one, we have 2x squared plus 2x squared, and that changed to our 4x squared, and we had 12x plus 22x, and that's going to change to our 34x. And then we had plus 42 at the end, and this is actually going to be the one that we end up using for the rest of these slides. Our next step is to pull out the greatest common factor of the three terms. So what we want to do is we want to take our numbers and we want to go ahead and find their prime factorization. So for 4, its prime factorization is 2 squared, 34 is going to be 2 times 17, and 42 is 2 times 3 times 7. As we can see, the only thing that they actually share in common is going to be this 2. So that makes that our greatest common factor. And so we can go ahead and pull that out, and we're going to start a set of parentheses and write down everything that's left for each term. So in the first term, we had a 2x squared left. In the second term, we had 17x, and in that last one, we had 21. Then we want to make sure that we identify our values for a, b, and c from our general form. So the number in front of our x squared is our a, and that's 2. In front of our x is our b, and that's 17. And our last constant is going to be our c, and that's going to be 21. Then we want to multiply together our a and c. So we have 2 times 21, and that gave us 42. And the next step is to find two numbers that will multiply together to 42 and actually add or subtract to get to our b. So we want two numbers that multiply to 42 and subtract to 17. I already went through and did all of the calculations for us. So as you can see, there's a lot of different options here. You don't actually have to calculate all of them out for every option. You just want to go as far as it takes for you to find the correct one. So using educated guesses might be helpful. In this case, we saw that 3 and 14 gave us 17. So we're going to use that, and we want to use those to break b into two different terms with our coefficients of 3 and 14. So if we look here, we had our 17x is going to be the same thing as 3x plus 14x. And because they're the same thing, I can go ahead and substitute that back into the equation, and we end up with this new polynomial. After this, we want to go ahead and look at just the first two terms and the last two terms of our polynomial, and we're going to group those, and we're going to go ahead and pull out the greatest common factor of those two terms. So if we look here, we have the first one, and we have 2x squared plus 3x. If we break that apart, 2x squared is actually just 2 times x, and 3x is just 3x. So the only thing that they share in common is going to be that x, and that's going to be our greatest common factor. We go ahead and pull that out, and once again, we're going to pull it out the same way we did last time. So we're going to have an x, and then we're going to have parentheses 2x from our first term and 3 left from our second term. When we do the same thing for the second one, you can see it over here. Once we finish off, we have these two factored out portions, and we can go ahead and replace those for their corresponding spots, and our polynomial will look as above. Once we're there, we can realize that we have two new terms in our polynomial. We have our x times 2x plus 3 and our 7 times 2x plus 3. And we want to go ahead and find the greatest common factor between those two terms. Now, I wrote it out below, but we can say that our greatest common factor is 2x plus 3 because it gets multiplied by both of them, and it's the only thing they both have. So then we can go ahead and pull out 2x plus 3. When we do that, we're left with x for our first term, and we're going to be left with a 7 for our second term. So we end up getting 2x plus 3 times x plus 7. And when we substitute that back in, we're here, and that's actually our final step where we're actually doing the solving process. So this should be our final answer. Our last step is going to be to go back and check our work. So we're going to go through the FOIL process, and we get to this equation, combine our like terms, and redistribute, and we end up back where we started. The second method is going to be the guess and check, and it's going to start off very, very similar, actually exactly the same. We want to start by combining our like terms again. So again, it's the same numbers as before. We have 9x plus 5x gives us 14x, 2x squared negative plus 2x squared ends up canceling out, and our 9x plus x gives us 10x. And of course, we can go ahead and look and see what happens at our bottom one. We're going to use the same example again. So we want to pull out our greatest common factor again, and we have the steps written out here for you in case you didn't actually make it through the AC method. But our greatest common factor is 2, and we're going to go ahead and pull that out of our polynomial. And we, once again, take our greatest common factor, open a set of parentheses, and write out what was left for each term. We want to make sure we keep our signs the same, and then put that final parenthesis in there to close it off. The next step is to take our A and our C, and we're going to take all of their different combinations of multiples. So 2 for our A comes out with just 2 times 1. It's our only option. And for 21, we have 2 times 1 and 3 times 7. So as you can see with the guess and check method, sometimes it kind of looks like it might cut some of your options down. We can also try combinations. The next thing we want to try is our combinations between A and C. So we can go ahead and look at the first one. We're going to do 2 times 1 and 1 times 21. If we look at these calculations, we get 2 times 1 equals 2, 1 times 21 would equal 21. If we add those together, it gets us to 23. We could also switch their positions, so we have 2 times 21 and 1 times 1. That's still not going to get us where we want to at our 17. It's going to get us to 43 instead. So let's go ahead and try 2 times 1 and 3 times 7, which sounds like it might actually get us a little bit closer considering those numbers are closer to 17. So when we go ahead and look, we tried our first time here, our second option here, and we found out that our answer is actually going to be this last one that I ended up trying. And it was 2 times 7 equals 14, and 1 times 3 equals 3, so 14 plus 3 is equal to 17. So the last step is to decide on the position and the sign. For all polynomials, when we're using our guess and check, we're going to go ahead and start with 2 sets of brackets, and then we're going to fill in the information inside. We want our x's to be at our first terms, and we're going to put just our constant numbers at the end. So this is all of the different combinations between the signs that we could have chosen. And there's a little idea checklist to help us break through and decide which one's correct. So the first thing I look at is whether or not C is positive or negative. If it was negative, we'd have different signs. If it's positive, we have the same signs for both of our equations. So this one being positive, I know I'm going to use the same sign, so I can go ahead and cross off 4 of these. The next step in mine is to look at whether or not B is positive or negative. So in our case, P is positive, which means we're going to have the same signs for both of them. If B was negative, we're going to have addition signs for both of them, sorry. If B is negative, then we'll have subtraction signs for both of them. In our case, B is positive, so we can go ahead and get rid of these 2 that have subtraction. And the last thing is to make sure that you put your numbers in the right place. So we want to make sure that we know that from our FOIL, the outside 2 numbers are going to get multiplied together, and the inside 2 numbers are going to get multiplied together to give us that middle term. And we want to have our 2 multiplied by our 7 is what we figured out earlier to give us our 14. So then we want to make sure that we either have 2 and 7 both on the outside or both on the inside of our equation. So this one shows us where 2 and 7 are both on the outside, which means that's probably going to be our correct answer. And we could go ahead and check again. So we would have our 2x squared plus 14x plus 3x plus 21. And when we simplify down, it should give us our same answer. If you're ever running into problems, there's lots of shortcuts for the guess and check. In particular, I really liked this video. It's actually students giving you some hints on what they thought about guess and check and some ideas that they use to help them simplify answers. And don't worry if you ever get to a polynomial that you feel is just impossible and you've tried everything and you think everything and you just can't get there. That's okay, because it's true that some of our polynomials are impossible. Well, at least for now with these methods, they're impossible. Actually, a decent chunk of polynomials in general aren't able to factor using real numbers. And of course, you're still going to run into those polynomials that look really, really scary, but don't worry, they're still manageable. And that is our factoring.